Okay, so we are kind of shifting gears into talking about angles. Um, we're going to talk about the beginning of the chapter is going to be a lot of vocabulary so that we can talk about angles and do some involved problems with angles. But before we can get to that, we need to define what an angle in standard position is. We need to be able to convert between degrees and radians as far as the units are concerned. And then these coterminal angles and reference angles are going to be useful when trying to solve more complex problems. So let's talk about what all of those things are here. Um, every angle, no matter where it's drawn, whether it's standard position or floating in the air, whatever it is, will always have an initial side and a terminal side. And we say that the angle kind of swings open from its initial side to its terminal side. So there is like a direction of swing for any given angle. Right. So when I say terminal side, that's the side that, if you think about it as like a kind of like two chopsticks opening. You can think about this initial side being stationary and the terminal side swinging open to a certain measure. Uh, the measure of an angle is just measuring the opening of an angle. And when we talk about standard position is when the vertex of the angle, which is the corner of the angle, is on the origin and the initial side lays on the x-axis. And then when we swing open the angle, wherever the terminal side lands, it does, and that's called standard position. So this angle is in standard position. A complete circular rotation contains 360 degrees. So if my angle swings all the way around and the terminal side lands back on the initial side, we would say that that angle that goes all the way around is 360 degrees, right? And placing the initial side on the x-axis gives us these nice quadrantal angles, which we'll talk about on the next page. But the y-axis, the negative x-axis, the negative y-axis, those are going to give us nice breaking points for each 90-degree angle, because the x and y axes are perpendicular to each other, so we get nice perpendicular quadrantal angles. Uh, Placing the initial side on the x-axis also gives us this idea of swinging the angle open counterclockwise versus swinging it open clockwise. And that's going to give us positive and negative angle measures. So the direction in which your angle opens determines whether you're talking about a positive angle measure or a negative angle measure, and vice versa. So if you talk about a positive angle, if you have a positive angle measure, that means your initial side is on the x-axis and your angle is swinging open in a counterclockwise direction. And for a negative angle, your initial side is on the x-axis and your angle is opening in a clockwise direction. Now, you can think about this angle that's given here as a positive angle because it's swung open this way, but you can imagine that if I were to swing an angle open the other way and land at the same spot, where my terminal side is on the same in the same spot, you can also reference this angle with a negative angle measure, right? You would just need to calculate how much it needs to swing open the other way in the negative direction to end up having the same position. So we can have positive angles, negative angles. The same angle can be referred to as a positive or a negative, sorry, a negative or a positive. But generally, we sorry, I don't know what I was going to say there. Yeah, we can refer to angles with positive measures or negative measures, depending on what we are trying to do with them. These things called the quadrantal angles are going to be angles that use the x and y axes. An angle where the initial side and the terminal side are both on the x-axis, where there's no opening, is going to be a 0-degree angle. If we open exactly to the positive y-axis, that's a 90-degree angle. If we open halfway across, meaning we go from the positive x-axis to the negative x-axis, that is a straight angle, also known as 180 degrees. And then each one of these is adding a 90. So if I open up to the negative y-axis, that's going to be an angle of 270 degrees. And then we know that if we go all the way around and get back to the origin, get back to the positive x-axis, we can also refer to that as 360 degrees. And I'll draw that on that first one there. Any questions so far on anything we've talked about? Is this is there anything new here for anyone, or is this all stuff that you've seen before? I don't mean the video. I mean just like in the past.
Yeah, this is pretty familiar.
Okay. Okay. Hopefully that's everybody as well, so that this is pretty straightforward. How to draw an angle in standard position. We sorry, I was reading through that. That's just like a whole bunch of unnecessary. Express the angle measure as a fraction of 360. Reduce the fraction to simplest form. Draw an angle that contains the same fraction of the circle, beginning on the positive x-axis and moving counterclockwise for positive angles and clockwise for negative angles. You're going to want to have these quadrantal angles as kind of markers for yourself to figure out which quadrant your angle's terminal side lands in. So any angle that's between 0 and 90 degrees will land in the first quadrant. Any angle that's between 90 and 180 will land in the second quadrant. Any angle that's between 180 and 270 will land in the third quadrant. And anything between 270 and 360 will land in the fourth quadrant. So when you're drawing these, just keep those quadrantal angles in mind. So if I'm sketching 30-degree angle, according to this box here, we are supposed to do 30 divided by 360, because each 1 degree is 1/360th of a full revolution. That reduces to 1 out of 12, which is not super helpful. I feel like 30 degrees is easier to find on these axes. But if you're drawing the 30-degree angle, we would start with a initial side on the x-axis. So that's my initial side. And then my terminal side is going to go to 30 degrees. Since 30 degrees is less than 90 degrees, I'm going to assume that the angle is in here. It's about a third of the 90 degrees. So we would have something like that. And I would say this is 30 degrees. The direction in which this opens is pretty important, right? Because when we do negative angles, we're going to open that the other way. We're going to swing the other way around. So if I do another angle here, the negative 135, which quadrant does negative 135 land in, or the terminal side land in? The third? How do you know that?
It's going clockwise,
Mm-hmm.
and it'll land on the third quadrant. But 135, if it was going counterclockwise, it would land in the second quadrant. But since we're going backwards, it'll land in the third quadrant.
How do you know that if we're going counterclockwise, it would land in the second quadrant?
Because positive 135 is between 0 and 180 degrees.
So it's up here. How do you know it's not in the first quadrant? You said between 0 and 180, right? That's everything up here is between 0 and 180.
it's because 135 degrees is between 90 degrees and 180 degrees.
Good. Good. So even when we're going clockwise here, opening up in the negative direction, we can think about this negative y-axis. This would be a negative 90 degree measure, right? And then if I keep going, that would be a negative 180 degree measure. So I know it's between negative 90 and negative 180, which means my angle is going to be in the third quadrant here. And you can actually figure out exactly where it is if you figure out how far it is from negative 90, how far it is from negative 180. This is going to be 45 degrees away from both, which means it should be right in the middle of the third quadrant, right? I will label this one with a negative 135 degrees and opening in that direction. So when you draw an angle, it is pretty important to draw this little arrow on the way that the angle swings open, so we know which direction you're opening that angle in, depending on the positive or negative angle. All right, now that we know how to draw them in standard position based on the quadrantal angles, we will talk about converting between radians and degrees. So radians is going to be a new, I don't know if you've seen radians before, but we're going to consider it as a new unit for angle measures. Degrees split up a complete revolution into 360 parts. And that seems kind of an arbitrary choice. There's no reason why that 1/360th of a revolution was called a degree. It's just something that was decided from the beginning, and it's just stuck. So we use 360 degrees for the angle measure of a full circle. But if we're not talking about degrees, there's actually a nice way to measure angles, and this one is actually based on the radius of the circle. So how radians came to be is someone, I don't remember who it was. Does it say in here who came up with radians? I don't see it. Okay, using the radius, calling it radians, how this works is we take the radius of the circle, that red line, and we take the length of the radius. So if you want to imagine putting a string on here and cutting it to the exact length of the radius, what we do next is we put one end of the string on the circle, and then we put the string around the circle, and we measure one radius length, right? So you can think about this as one radius length. Sorry, I think it was starting at this red dot. I kind of mislabeled that. Let me draw it on here. From here to here, that's one radius length. I think I used the other red dot on accident. So from there to there, that's one radius length. And then we keep doing that. So we start at this point here where we stopped. We put the radius on the circle again. That's another radius length, and so on, right? So the length of the radius is 1 radian. So 1 radian is essentially one length of the radius around the circle. Now, you might be thinking, well, what if the circle is bigger or smaller? Doesn't that mess with the length of the radius? And it does, but the angle that this forms when you place the length of the radius on the circle and you draw this angle that is subtended by one length of a radius, this angle does not change. If you make the circle bigger, the radius gets bigger, but so does the length of the radius that goes around the circle. So if you made the circle bigger, you would still have, if the circle was bigger, you would still have the same angle with a new longer radius, but the central angle will remain the same. Okay, the length of the circle that the radius covers would increase, but so would the radius. So that angle remains the same. We call this angle in here 1 radian. And if you want to think about, well, how many degrees is that? If we want to have some kind of conversion between 1 radian and 1 radian and a certain degree measure, we have that down here, and it comes directly from the circumference formula. I know that the number of radiuses it takes to go around a circle is exactly 2 pi, because circumference is given by 2 pi times the radius. That's telling me that there are 2 pi radiuses, or 2 pi radii, around the circle, if I keep doing what I was doing earlier. So 2 pi radians is going to be a full circle, a full revolution around the circle. So 2 pi radians is equal to 360 degrees, which gives us a nice conversion where we divide both sides by 2, we get pi radians is 180 degrees. In other words, 1 radian is 180 over pi. We don't really use this 57.3 degree measure. That's just so you have an idea of like how big 1 radian is. It's always going to be 57.3 degrees, but we don't necessarily use that in conversions. We can also solve the same equation, the 2 pi equals 360, for 1 degree, which would give us pi over 180. You notice that these two are just reciprocals of each other, right? We either have pi over 180 degrees, pi over 180, which is 1 degree, or we have 180 degrees divided by pi, which is 1 radian. So keep those two in mind. I guess just keep one in mind, just that the pi radians is equal to 180 degrees, and you can use that to convert between degrees and radians. So this box is pretty important here for whenever you want to convert between radians and degrees. If you have an angle in degrees, we take that angle in degrees, we multiply it by pi over 180, and we get the same angle in radian measure. If we have an angle in radians, we multiply by the reciprocal 180 degrees over pi, and we get the angle measure in degrees. All right, so simply, if I was trying to convert each radian measure to degrees, I know that I'm trying to do radians to degrees, so we're going to take each of these angle measures, pi over 6, we're going to multiply by 180 degrees over pi, and sometimes the pi's are going to cancel, and we can reduce the 6 and the 180. What's 180 divided by 6? That's 30 and 1 here, so we end up with 30 degrees for a radian measure of pi over 6. And then if we're trying to convert from degrees to radians, we multiply by pi over 180. So we're going to take 15 degrees multiplied by pi over 180, which probably reduces, right? 15 goes into 180. How many times? 10, 12 times, which tells me that this is a pi over 12. Now, notation wise, we know that degrees uses this little circle superscript to mean degrees. Radians don't have a unit, like you don't write radians afterwards, or there's no little symbol for radians. So if you give an angle measure as just a number, like pi over 12, that's understood to be radians. Okay, as long as it doesn't have the little degree symbol, it's understood to be a radian measure. So this 3 on 4.1.2, that's a radian measure. So radian measures don't necessarily have to have pi in them. This is a very common issue that students run into. They expect to see some kind of pi expression in the radian measures, but you don't have to. In my picture over here, I said that this was 1 radian, right? If I were to open this to 3, this would be 3 radians, right? They're not always necessarily going to be some kind of pi expression, right? We can have whole number radian measures, and you convert the same way. You multiply by 180 over pi to convert to degrees. Any questions on radians and degrees? Radians and degrees, you guys can fill out this circle if you didn't already do so in the video. Go ahead and convert each of those measures, whether you're converting from radians to degrees or degrees to radians. Make sure the circle is filled out. It's going to be useful for having these sets of angles, or knowing these sets of angles and where they are on this circle. So make sure you fill that out. Finally, I want to talk about coterminal angles and also reference angles. Coterminal angles are just angles where the terminal side lands in the same spot for two different angle measures. So earlier I kind of alluded to this by saying, if I look at this example here on the right, an angle of 140 degrees, if I open it in the positive direction, positive 140, lands in the second quadrant here, exactly there. But I can also say that negative 220, an angle of negative 220 also lands on that same spot. So any two angle measures where the terminal side lands in the same spot are called coterminal angles. Co meaning same, terminal meaning terminal side of the angle. So coterminal meaning any two angle measures that have the same terminal side. The easiest way to find more and more coterminal angles is by adding or subtracting 360 degrees. So add 360 degrees or subtract 360 degrees to find coterminal angles. So if I have an angle like 800 degrees, that's definitely more than one revolution, right? One revolution is 360 degrees. So this 800 is going 360 around, and then another 360 around. That would be 720. And then 800 probably lands in the first quadrant here, so it looks like this. That's what an 800 degree angle looks like. If I were to draw it on the axes, you'd have to say it spirals around twice, and then it lands somewhere in the first quadrant. But I really don't want to do the spiraling around, so we can find an angle that's less than 360 or within one revolution that lands in the same spot. The terminal side lands in the same spot, and all we do for that is we take our 800 degrees and we're going to subtract 360 from it, and that's going to give us 440. We ask ourselves, is that between 0 and 360? And the answer is no, that's still more than one revolution. So I'm going to take my 440 and I'm going to subtract 360 again to shrink it one more revolution, and that'll give me 80 degrees. And that definitely is between 0 and 360. That's in the first quadrant, which means 80 degrees and 800 degrees. Now, while they're not the same exact angle measure, they're going to look the same on this XY coordinate when drawn. The initial side and the terminal side will be the same. All right, so it's pretty easy to find coterminal angles. You just add or subtract 360. If it's a negative angle measure that you're starting with, you probably want to add 360 until you get to something between 0 and 360. If it's more than 360, you want to subtract down to a single revolution. Okay, you can also do the same thing with radians, and we know that that 360 degrees is the same thing as 2 pi. So instead of adding and subtracting 360, we'll add and subtract 2 pi to get to something that's between that's in one revolution, which is 0 to 2 pi. So if I look at this, 19 pi over 4, how I know this is more than one revolution? How do I know this is more than one revolution?
Because it's greater than 2 pi.
How do you know it's greater than 2 pi? It looks weird. It has like a denominator, so it's really hard for me to compare this to 2 pi. How do you do that comparison?
I mean, you just divide 19 over 4.
If you do 19 divided by 4, and you just kind of approximate
And the
that,
pi would be left over, and that's bigger than 2 pi.
what would be left over?
Or you just divide the 19 by 4, and then that's like 4.75.
Good.
It's 4.75 pi.
Good. You can do that, or you can think about what 2 pi is in terms of this denominator, which is pretty helpful as well. 2 pi in terms of a denominator of 4 would be 8 pi over 4, right? That's what 2 pi would be. So 1 full revolution would be 8 pi over 4. If I kind of just artificially enlarge this 2 pi to a fraction that has a denominator of 4. So if it's anything bigger than 8 pi over 4, which 19 pi is bigger than 8 pi, so now we can just compare numerators. I know that this is bigger than 18 pi over 4, right? And then if you have a negative angle measure, you obviously aren't between 0 and 2 pi because you're a negative. This is a negative measure, so we're going to start adding 2 pi to this until we get a positive angle measure between 0 and 2 pi. Okay, so that's all about coterminal angles. Let's talk about reference angles, which is a little bit different. This is not necessarily an angle that's between 0 and 360. This is more specifically an angle between 0 and 90 that we can use as a reference angle for anything in the 4 quadrants. So there's 4 different pictures drawn here. I don't need you to necessarily memorize what happens in each quadrant. More so, it makes more sense to learn how to find a reference angle, and then it'll make sense when you go to any one of the 4 quadrants. You're always looking for a angle formed, this part's important, angle formed by the terminal side of the angle and the horizontal axis. That's the angle we're looking for here. And obviously that's going to be different for the four quadrants, because if I have an angle in the first quadrant, then the angle that the terminal side forms with the x-axis is itself, right? If my angle is already in the first quadrant, then that angle is its own reference angle. If an angle is in the second quadrant here, this red angle here, then the angle formed by the terminal side, the red side, and the x-axis is going to be this angle here. That's what the reference angle will be. In the third quadrant, this red angle is my this red side is my terminal side. This was the original angle, right? Opened all the way to here, something between 180 and 270. The reference angle for that would be the terminal side and the x-axis. We make an acute angle with the terminal side and the x-axis, and that is our reference angle. And then in the fourth quadrant, we take our terminal side and the x-axis, and we form a nice acute angle. That's our reference angle. Okay, so reference angle is always forming an acute angle with the terminal side and the horizontal axis. Always with the horizontal, never with the vertical axis. This is a very common mistake that students make. They'll draw, I guess, we already know where 800 degrees lands, right? So 800 degrees, we just did this where we found the coterminal angle. This was in the first quadrant. It was 80 degrees, right? So if it's in the first quadrant, if that's my terminal side, actually let me do that in red. If my terminal side is here, then my reference angle is going to be the acute angle formed by that terminal side and the x-axis. So that would be the acute angle. What's the measure of this angle?
$80.
80 degrees, yeah. We found that 800 lands at the same place as 80, so this must be an 80 degree angle. So the reference angle is going to be 80 degrees for that one. Note that the reference angle is always between 0 and 90, so it's always a positive angle measure, which means we don't really consider like the direction of opening on this one. We just measure the acute angle between the x-axis and the terminal side of the angle. So you guys can work through some of those. Find the angle in quadrant 2 with each of the given reference angles. That's an interesting problem. So if it says it wants an angle in quadrant 2, you want to draw these angles as reference angles in quadrant 2. So I'll do one with a radian measure this time, just so you see a different example. I'm going to draw this. A lot of times it's going to be nice to draw a little picture for yourself. If I'm going to draw an angle in the second quadrant, I'll just draw it in the second quadrant. Right, that's my terminal side. That's my initial side, always on the x-axis. And I'm told that the reference angle is pi over 4, which means this angle here is pi over 4. But I want to know the angle in standard position, which means I want to know what this angle is here, opening from the positive x-axis to that terminal side. How would I find this angle opening here? Any ideas?
Is it pi minus pi over 4?
Okay, yes. How are you deciding to use pi minus pi over 4?
It's because I know on the second quadrant that'd be 180, and then 180 converted to radians is pi.
Good. So if I were to swing this all the way around to the negative x-axis, right? If it was a straight angle, it would have a measure of pi. Well, we know that this part of that is pi over 4, and I kind of just want the rest of it, right? So we just complete it to one of the quadrantal angles, which is you're either going to complete it to 180 or you'll be completing it to like 360. So we'll do pi minus pi over 4. How do we do this subtraction? How do I subtract those? What do I need? Common denominator, thank you. Which pi is 4 pi over 4. So minus a pi over 4 gives me 3 pi over 4. That means this angle here is 3 pi over 4. And you can confirm that by adding these two together and seeing that we get a full half circle of pi. Any questions on anything?